Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 4, structure of the atom. So like in part 2 we already discussed on basic thing on structures of atom, right? We discussed on what like how the discovery of protons, electrons and neutrons happened, and which are the different atomic model that were put forward to explain the structure of an atom, right? So we have studied about J.J. Thomson's model, where we know that J.J. Thomson, he has introduced electron to us, and the best example that he gave to us was the, you can say, example of watermelon, where the red part of the watermelon, it acts as the nucleus containing the neutrons and the protons, and the black seeds in it, the seeds which are been embedded in it, it act as the electron. So that is how the structure of the atom is, right? So we have discussed in detail everything about J.J. Thomson's model, and even we discussed on like who exactly he was and what exactly he did, right? So now I want each one of you, because we have already done part 1, which was very much introductory, right? We had more information about electrons, protons and neutrons in part 1. So I want you all to please revise whatever notes that you have taken in your book, and then we can proceed further with the further part. Okay. I hope everyone is revising the notes that you have written in your book. Okay. So I hope every one of you have revised whatever you have taken like notes on. Now I'm going to show you the slides one by one, and I want each one of you to please go through it and like have a cross check whether you have like taken down all the important points or not, and you need to even revise it whatever has been written on the screen, because my main motto is you revising the thing, because according to me revision is very important. Unless and until you don't revise or do the revision, you won't understand the concepts properly. Okay, you have to put your you can say some efforts towards the topic so that you understand it, right? So if you put your 20% efforts in it, you will like know the topic 40% better. Okay, so please do that. 20% efforts is in sense of revision, rest all is like you understanding it yourself. Okay, revision plays a very important role. So now I'm going to, like as I said, I'll be showing you one slides till wherever we have done. You have to read all the slides and revise each and every part very properly. Okay. I hope every one of you are going through the slide properly. After this, like discussing more about atoms, as we studied that atoms are the fundamental, like atoms and molecules, they both are the fundamental building blocks of matter, and they can exist in different forms, right? So here we have some of the information, like because earlier, because people didn't had much information on atoms, they were not knowing about the internal structure of atoms. Like as of now we know that atom includes protons, electrons, neutrons. These are the like included in the structure of the atom, right? So earlier, like people used to think that atom is divisible, but as and when like they came to know about the concepts, they realized that atom is indivisible and indestructible. We cannot divide it, neither can we destruct the atom. Okay, so I hope every one of you are going through this slide. After this we discussed on like Charged particles in matter. So as we know, protons are positively charged, neutrons are neutral, they do not have any charge, and we have electrons. Electrons are negatively charged, right? So I just want you all to please go through this. After this, charged particles in matter, we discussed on this activity, right? When you rub the comb on your dry hair and then bring it close to pieces of paper, it will attract, right? And then, like, if we have a glass rod, and when we rub this glass rod with a silk cloth and bring the rod near an balloon, that will also show a kind of attraction, right? So as it was stated in this part, that static electricity, like the first indication that atoms are not indivisible, it means that they cannot be divided further. It came from this concept only by studying static electricity and the condition under which electricity has been conducted by different substances. Okay, so that is why this activity was been done. So I want you all to please go through this activity, and if possible, if you can perform the activity, it will be like better. After this, like here we have like discussed on how E. Goldstein in 1886 discovered the presence of new radiations in gas, and he called those discharge as like there were certain rays which came from it. So that was known as canal rays, and the canal rays are positively charged radiation, which ultimately led to the discovery of protons. And we know that the mass of the proton was 2000 times as that of electrons. They were equal in magnitude but opposite in sign, right? Then protons are been represented as P plus, electrons are represented as E minus. Protons have plus one charge, neutrons has minus one charge, right? So there are many important information which has been given on this slide. So I want you all to revise it properly. I hope everyone is going through each and every statement that has been given, because as I told you, we have like more information over it. I hope everyone is going through it. Now, after that, we discussed on the structure of atom. So I want each one of you to please go through this. Then we discussed on Thomson's model of an atom. So I want you all to please go through it. So here we studied about like who exactly J.J. Thomson was. So J.J. Thomson, he was like born in 1856. Like the exact date has also been given. Like he was born on 18th December 1856 and he died in 1940, right? So he was a British physicist who was born in Chatham Hill, which is a suburb of Manchester, and he was awarded Nobel Prize in Physics in 1906 for his work on discovery of electrons. Okay, so while he was working, he directed the Cavendish lab at Cambridge for 35 years, and like the 7 research assistants which were like working with him, they won Nobel prizes as well. So just imagine the, you can say, the work that they were trying to do, right? So after J.J. Thomson, we even discussed on like what exactly Thomson had proposed, right? So these are the two important statements which have been given by Thomson, that an atom consists of positively charged sphere and the electrons are embedded in it. And the second, you can say, proposal given by Thomson was the negative and positive charges are equal, okay, in magnitude. So the atom as a whole is going to be electrically neutral. Okay, so the results of experiment carried out by other scientists could not be explained by this model, and this is the, you can say, Thomson's model of an atom, which is also called as plum pudding model. Okay, I hope everyone is going through it, and even the diagram. So whenever you're writing about Thomson's model, you have to make sure that you are like even drawing this and writing the two different points which have been given. Okay. After this, now we need to discuss about Rutherford's model of an atom. So how many of you are aware about like who exactly Rutherford was? Because like if you all remember in part 1, I have already explained you about it, right? So if anyone will be able to like write few points on Rutherford's, if I tell you to write it, will you all be able to write a short note on it? Not the exact thing, but a short idea on it. See, Rutherford's full name was Ernest Rutherford. He was interested in knowing how the electrons are arranged within an atom, because Thomson's model, it revealed about electrons, right? Now the question was, what exactly Ernest Rutherford has how exactly these electrons are been arranged in an atom. So Rutherford designed an experiment for this, and in this experiment, fast moving alpha particles were made to fall on a thin gold foil. What was that? A fast moving alpha particle. Okay. So fast moving alpha particle was made to fall on a thin gold foil. Now there were certain reasons why those gold foils were being used. So he selected a gold foil because he wanted a thin layer as possible. He wanted the thinnest layer as possible. So this gold foil was about like 1,000 atoms thick. Okay, so the reason of using gold foil is Ernest Rutherford, he wanted a thin layer as possible, and this gold foil was 1,000 times like 1,000 atoms thick. So this is one of the reason of choosing a gold foil by Rutherford. Then, now the question is, why did he choose the alpha particles? Because it is very well stated above that in this experiment he had like fast moving alpha particles were made to fall on the gold foil. Now you know the reason of using a gold foil, right? Now what is the reason of using only alpha particle? Why not the beta and the gamma rays? So see, because alpha particles are doubly charged helium ions, and because we know that heliums like you can say heliums have mass of 4u atomic mass unit, right? So because heliums have mass of 4u, the fast moving alpha particle will have considerable amount of energy there, right? So one reason of, you can say, using this doubly alpha particle was because they are doubly charged helium ions and they have mass of 4u. So because of which this fast moving alpha particle will have considerable amount of energy, and it was expected that alpha particles will be deflected by the subatomic particles in the gold atom. What was expected? It was expected that the alpha particles, they will have like they will get deflected by the subatomic particles, okay, and the subatomic particles are in the gold atom. So since the alpha particles were much heavier than the protons, he did not expect to see large deflection. So because alpha particles were heavier than protons, which are positively charged, so protons, they are not going to show any deflection, because as in when he is very much interested in electrons, he doesn't want to know about protons, right? So this is one of the reason. I hope you all are writing it, like you all have written it and you're even drawing the figure that has been given, where the nucleus, electrons and the electron orbits have been shown. I hope everyone is taking all the important points. You have to write that he had used a gold foil and alpha particles. The reason why it was used, okay, and why while the alpha particles were used, why only electrons were seen, because atom consists of electrons, protons, and neutrons, right? So why only, you can say, electrons were seen. Okay, so that also the reason of that has also been given, because the alpha particles were much heavier than the proton. He did not expect to see large deflections over there. Got it, everyone? Sorry. So see, now whatever result he got, the results were like very, you can say, very unexpected, because following observations were found out that most of the fast moving alpha particles, what happened, those fast moving alpha particles, they pass straight through the gold foil, and some of the alpha particles, they deflected by the foil by a small angle. So this was not expected, right? Because as I said that some of the unexpected results were being obtained. So So those unexpected results like are that fast moving alpha particles, they like traveled straight through the gold foil. Okay. Some of the alpha particles, they got deflected by the foil by small angles, and surprisingly, one out of every 12,000 particles, they appeared to rebound. Rebound means they were going deflecting and then again coming back. So they were getting rebound. So in the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. How is this result? It's like incredible as if you fire a 15-inch shell at a piece of tissue paper and then it is coming back to you again. Rebound means it is going, getting deflected and coming back again. So that is what was happening over here with the gold foil and the alpha particles. Okay. So I want each one of you to please go through this once. Please write this results, and even you can show the scattering of alpha particles by the gold foil, how exactly it occurs. Okay. I hope everyone is drawing this scattering and all. I hope everyone is writing the results and even drawing the scattering of alpha particles, how exactly it happens through the use of gold foil. Okay? I hope everyone is drawing it like you need to show the scatterings. That few alpha particles are traveling straight while few are getting deflected. Okay, so you need to know this. I want each one of you to please write this thing in your book and even draw the scattering part. Okay. So after this, now we have like to discuss on Rutherford. So we have E. Rutherford, Ernest Rutherford, who was born in 1871 and he died in 1937. Okay, and he was born at Spring Grove on, you can say, 30th August 1871, and he was known as the father of nuclear physics. What was he known as? He was known as the father of nuclear physics, and he was famous for his work on radioactivity and the discovery of the nucleus of an atom with the gold foil experiment. So because he had even worked on radioactivity, he was been known for that work, as well as for the discovery of nucleus of an atom, because he played a very important role discovering the nucleus of an atom. Okay, so for that, for his work, he got a Nobel Prize in Chemistry in 1908. So this is the achievement of Rutherford. Okay, and he is very well known for the discovery of nucleus now, because we are studying about the nucleus, electrons, protons, and also he is known for the discovery of the nucleus and the gold foil experiment that he had performed. Okay, so if you want, you can just take a note of some points. After this, now we have the drawbacks of Rutherford's model to discuss. Okay, drawbacks means, like, you can say, because of which the Rutherford's model has not been used, but he has like given a lot of contribution. Okay, so see, the revolution of the electron in a circular orbit is not expected to be stable. Okay, so because when the electrons are revolving in circular orbit, it is not expected to be stable, and any particle in a circular orbit would undergo acceleration. Okay, what will happen? Any particle in a circular orbit is going to undergo acceleration, and during acceleration, the charged particle will radiate energy. We know when any subject accelerates, like when we have that acceleration which has been given in our scooties, like if you ride a, because you ride a bicycle, you might be knowing how to accelerate your bicycle, how to increase the speed, right? So whenever there's going to be acceleration, whatever charged particles which will be present, they're going to radiate energy, and thus the revolving electron, they will lose energy and finally fall into the nucleus. So this were so, the atoms will be highly unstable, and hence matter will not exist in the form that we know. Okay, because here the atoms are going to be highly unstable for us. So we know that atoms are quite stable, right? So here we have the drawbacks of Rutherford's model, which has been given, where they have shown the spiraling of an accelerating electron into the nucleus with progressive loss of energy. So as they are accelerating, as they are moving, what will happen? Energy loss will take place over there. So they're going to radiate some amount of energy. Okay, So I want you all to draw this Rutherford's model of an atom, and even write the, you can say, the drawbacks which have been given. I hope everyone is drawing it. So I hope everyone like you all are done writing the drawbacks of Rutherford's model, and even you have like shown this spiraling accelerating electron into the nucleus, how exactly it is happening. Okay, so now we have the further part to discuss, that is the Bohr's model of an atom, which I'm not going to start today. We will be like doing and discussing about the Bohr's model tomorrow, but I hope whatever we discussed about Rutherford and Thomson's model, you're very much clear with it. Okay, so we'll start with the next part, that is Bohr's model of an atom in the next part. Okay, but please make sure that you all are revising whatever we have studied so far in the lesson. So we'll be studying about Bohr's model in the next part. Then we will be discussing on the on who exactly Neil Bohr was. We will be discussing about the four shells, K shell, L shell, M shell, and N shell. This four, both the four shell, like all the four shells are very important because they have certain number of electrons which they have within them. Okay. Then we'll discuss about neutrons in detail. Now we know neutrons contain, what do these neutrons contain? They have protons, sorry, nucleus contains protons and neutrons in it, right? So we have already had an information on neutrons and electrons, sorry, electrons and protons. So we'll discuss about neutrons as well in detail. Then we will discuss on how are electrons distributed in different orbit. Okay, what are we going to discuss? We'll discuss on how are electrons distributed in different orbits, because now I said you that there are four different orbits, right? Four different shells: K shell, M shell, N, K, L, M, and N. These are the four different shells that we have. So we will be discussing on how exactly these electrons have been distributed in different orbits. Okay. After that, we'll discuss on valency in detail, because we need to study about valency as well, which we will be discussing. And you need to know that the number of electrons present in the outermost shell, we know that as the valency of, you can say, like, of an atom. Okay, so we'll discuss that in detail. So here we have the table where we have the name of elements, the first 18 elements. Then along with that we have the symbol representing it, the atomic number of those specific elements. Along with that we have the number of protons, neutrons and electrons which have been given, and then how exactly the electrons have been distributed in four different shells, that is K shell, L shell, M shell and N shell. And then we will be discussing on the valency. What is the valency of each and every electrons, because we should be knowing that as well. Okay, after studying this, like, this table is very important, so we will be studying this. After studying this table, like, you will get an idea what exactly valency is. You will be knowing everything till here. We will be discussing on after that what is exactly atomic number, and then after discussing atomic number we will be even discussing on mass number. Okay, so as you can see, the atomic number has been given over here, which has been represented by Z. Okay, on the top of the element, then we have the atomic mass which has been written down the element. So we'll be discussing all of that in detail, what exactly atomic number is, what, how do we use it, how do we denote it, and everything. Then after atomic number we will discuss on mass number in detail. Okay, so as you can see, the atomic number is represented by Z, and the mass number is represented by A, and the symbol of the element is written as X. So we'll be discussing on in detail as well what is atomic number, what is mass number in detail, and then after that we have isotopes and isobars to discuss. So isotopes and isobars, like, for some of the students it might be like they might have eliminated this part on isotopes. Some of you might be having it, so we'll do it. Okay, just check it from your end if it is, like, you can say, omitted from your school, or like your school is going to have it. Okay, so we'll discuss about isotopes in detail. After discussing isotopes in detail, we will be discussing the applications of isotopes, like how exactly and why isotopes have been used. So we'll discuss the applications. Then after that we'll be discussing on what exactly isobars are, what are isobars, because you should be knowing that as well. And then we have the summary discussion in detail, like what exactly we have studied in the whole lesson, structure of an atom. So mostly in like 2 or 3 more parts we will be like able to complete the whole lesson, structure of an atom. So this is the summary that we will discuss in detail. Okay, and after summary we have some of the exercise questions which have been given. So I want each one of you to please go through this exercise question. So I guess there are total 19 questions that we will be discussing in detail. Okay. I hope every one of you are going through the questions that have been shown on the screen. So altogether we have like 19 questions to discuss. So that's why like I want you all to be clear with whatever we have discussed so far. That's why I'm not teaching you much, because whatever I'm teaching you, just be clear with that much part. Like in the last part I taught you about Thomson, in this part I taught you about Rutherford. Now next part we will start with Bohr's model, okay? So that it becomes easier for you then. So this will be the last question that we will be discussing about, okay? And this is how we will be like ending up with the lesson structure of the atom. And I hope whatever we discussed today in this part, you're very much clear with it. Now the next part of the lesson, I will be continuing that in the next class. But before that, as I tell you to like revise it, okay, you need to give some time on your own to the lesson, so that it is becoming easier and clear to you, okay? So, and even like you should be knowing, if we studied that Rutherford had used gold foil, and even he had like used alpha rays, right? So you should be knowing the reasons about them. Orally you should be able to tell it, okay? You should not be like, let me think and then I'll tell you. No, that kind of revision you need to have, okay? So please do revise whatever we have studied till now, and I'll be continuing with the next with the rest of the part in the next class. Thank you everyone.